XGBoost. You provide your code as a Python package. The custom containers option allows you to train models built with any framework or language by putting your training application code in a Docker container, push it to container registry, and run training on Vertex. You can accelerate the training with GPUs and also apply hyperparameter tuning. In the Models tab, you can see all the models you have created. Here, you can also import models trained outside of Google Cloud to serve it for online and batch predictions. In order to use a model, you create an endpoint, which brings us to our next step. Creating an endpoint is how you serve your models for online predictions. Each model can have multiple endpoints. Enter the compute resources so your endpoint can auto-scale to resources based on your traffic. You can even split traffic across endpoints and send model logs to cloud logging. Once the model is live, we can make predictions in the UI or through the SDK. In the Batch Predictions tab, you can make predictions on the batch of data from cloud storage. This was a pretty high-level overview where we saw that Vertex AI provides the tools to support your entire machine learning workflow from data management all the way to predictions. In the next episodes, we will dive much deeper into all of these steps and build end-to-end machine learning workflow. In the meantime, let's continue our discussion in the comments below. I'm excited to hear all about your machine learning use case and workflow.
Oh, went too hard.
Hi,
on
I'm
this.
Priyanka Vargadia, and this is AI Simplified, where we learn to make our data useful. In this video, we're going to imagine a company that has large amount of data which they want to use to make meaningful predictions and take their business to the next level. And we also know that their team has varying levels of machine learning expertise. To accelerate this AI innovation, they are looking at Vertex AI, which provides tools for every step of the machine learning workflow, from managing data sets to different ways of training the model, evaluating, deploying, and making predictions. In this episode, let's see the first step of the machine learning lifecycle, which is the data sets. You don't need to worry about data sets. If your use case is generic enough, you can just take advantage of the pre-trained machine learning APIs. And to learn more about them, I've included a link below. In order to create custom machine learning models, we must first have a collection of data to train our models with. That is what datasets are for. Datasets make data discoverable from a central place. They provide the ability to annotate and label the data right from within the UI. You can track the lineage for data governance and can compare model metrics between the models. Now, to create a dataset, we first select our data and upload it, import it into the managed datasets. And then we can make modifications and use it to start training the model. Currently, there are 4 supported data types: image, tabular, text, and videos. Now, image datasets currently support image classification, which is where models predict one or many labels from an image. Now, for example, identifying the types of dog treats from images of treats. Object detection is where the model draws bounding boxes around the items of the image. For example, you're identifying the location of different vegetables within a picture of salad. Image segmentation is where the model can assign a label to pixel-level regions in an image. To ensure your model performs well in production and there's no training serving skew, make sure the training images are close to the input your users will send to your deployed model. For example, if your images are going to be low resolution, be sure to have blurry images, low resolution images in there. Include multiple angles, backgrounds, and all sorts of resolutions. It's recommended that you include at least 1,000 images per label, but you can always get started with 10 per label. The more examples you provide, the better your model will be. Now, tabular datasets currently support regression, where you predict a numerical value and class.
I'm not gonna lie, y'all. This is a lot, so let me get back.
Hi, I'm Priyanka Vargadia, and this is AI Simplified, where we learn to make our data useful. In this video, we're going to imagine a company that has.
And let me queue up another video. This is kind of my style of learning new tools and like kind of adding them to my process. So I'm just gonna kind of walk through that instead of trying to. Let me give me a simple version of this. Maybe. This seems pretty cool. This seems pretty cool. So let me do this, and then I don't like that one. I'll go with this guy. One of these is going to make sense.
Hi everyone, and welcome to the Google I/O 2022. I'm Ivan Nardini, I'm a customer engineer at Google Cloud, and today I want to tell you a story. That story begins with you, who just joined a data science team of an important banking company. Congratulations! Now your team is part of the data office and is responsible for building innovative solutions across several business units. On day one, Maya, the product manager of the fraud detection system, has a meeting with you and your team. She shows a rules-driven engine composed of a set of if and else statements and logic are coded by SMEs in collaboration with software engineering team. For each transaction, she said that if it comes from the country X and the cardholder has several requests within the last hour with a certain amount, then the system assigns a fraud score of 0.95. With that, Maya has some concerns about the main challenges of the actual system. First of all, human rules are based by definition. They represent a subjective component, since different experts design rules in different ways. Secondly, the system is hard to scale because rules are required to be hard-coded. Each time a new fraud pattern is discovered by investigators, the team needs to manually express it as if and else statements and integrate them. Last but not least, it's also hard to maintain. Indeed, we ended up with absurd rules, each of them for each fraud scenario. And these maintainers are investigators and software engineers that tend to come and go, bringing with them information about how rules make the system. So because of those challenges, Maya expressed the needs of building a new system. She wants to implement a modern data-driven fraud detection engine. And because the company is going through the process of digital transformation, she asked you and your team to design it on Google Cloud. She wants a machine learning model to estimate the probability of each transaction to be a fraud. She expects that the model does not require any manual intervention. And it needs to be interpretable at the same time, in order to allow SME and investigators to validate its results and, if necessary, improve it. As I said, you are part of the team that has been assigned to design and build this system on Google Cloud. So my question is, where will you start from? Well, I'm a customer engineer, that's my job, and I spend my time talking with data science teams. And I noticed that the model and its associated technology tend to be seen as a shopping list, without considering the impact of their requirements and dependencies on the entire system. Also, it happens sometimes that phases like the model experimentation tend to drive choices about its component and how they should work. But the thing is that building machine learning models is just one phase, and it has nothing automagical. If you don't feed it with a good quality data, it will not generate good insights. And if you don't make it modular, you will not be able to adapt it when new pattern of data comes. And this is just to say that the model is important, but sometimes the big picture is missing. And when you need to productionalize your model, when you need to make it a product that will generate business value, well, the context matters most. To build it, you need culture and best practices. That's why MLOps came out. Indeed, the concept itself expresses the set of culture, practice, and technology that aim at unifying ML development with operations in order to put model into production. As Google, we were able to turn this concept concretely. For example, one of the largest production ML systems at Google has thousands of ML model training concurrently, continuously retrain with the new data every hour, and continuously deploy the global serving infrastructure. So we really know what MLOps means. And as Google Cloud, we want to share those expertise and technology with you. About the expertise, you have people like me that are ready to support you in your ML journey day by day. But talking about technology, that's the reason why we launched Vertex AI, which is the Google Cloud managed machine learning platform to help you accelerate experimentation and deployment of ML models at scale. All you need to know is that the platform has several building blocks that allow you to cover the entire lifecycle from data ingestion to model training all the way down to model prediction and model monitoring in order to productionalize your models. So now that you have the technology, the next question is, what would be building the new fraud detection system on Vertex AI? What will it look like? How will it be better compared to what you have? Well, I already know the answer to those questions. Why? Because I did it. In collaboration with some of my colleagues at Google Cloud, we built Fraud Finder. Fraud Finder is a project that comes from some customer needs to apply the state-of-the-art of data science and machine learning to detect fraudulent transactions at scale in real time. It's still a work in progress, but me and the team learned so many things along the road that we thought, why don't share our experience? So here I am. Are you with me? Let's go on. To build a simple fraud detection system as Fraud Finder, you start from data of historical transactions. Just to clarify, in your case, a transaction is an event recorded at 5 a.m. today associated with a customer with a particular ID who made a payment of a certain amount to an identified merchant. Now, part of that information cannot be consumed either by a model as they are. In fact, the model needs number, and only some of them are numericals. Also, you can think of applying several data transformation techniques to derive new variables which will be relevant to predict if a transaction is a fraud or not. Will the number of transaction customers made recently matter? What about the average transaction amount in the last week? Could the terminal be compromised for any customer who is using it? In other terms, you define a set of features to identify customer spending behavior and characterize the risk of fraud associated with the terminals over different time windows. And you can do that by using BigQuery, which allows you to analyze terabytes of data per second. At that time, you get your features, and you are ready to train your model. But let's consider some aspects for a second. First of all, in a real-time fraud detection system, some of these features cannot be calculated on the fly when you serve the model. How would you get the average amount of transaction over the last 3 days in milliseconds? You need a way to pass them as an inputs to the model if you want to generate online predictions. Now, BigQuery is not engineered for low latency reads. That's why you need to introduce an optimized data store for lookup operation at scale in low latency. But there is another aspect that needs to be highlighted. In that real-time system, you have a high volume of transaction you can use to calculate those features we keep floating and collected constantly over time. It implies that you always get fresh data to reconstruct features, and depending on when you decide to calculate one feature or another, you can end up with a set of features that are not aligned in time. For example, you can keep calculating the number of transactions over the last 3 days, each day at midnight, but at the same time, you will need to calculate the average amount of transaction over the last 3 hours along the day several times. And as you can imagine, this has implications when you need to train your model. Indeed, when labels become available, those features will not be aligned with them as well. In your case, you will know if a transaction is a fraud or not only after some time. The investigation is run and validated your predictions. Because of that, it sounds incredibly difficult to say which set of features contain the most up-to-date historical information associated with the label you want to predict. And when you're not able to guarantee that, the performance of your model would badly affect because you serve no representative features of the data and the label from the field when the model goes live. So you need a way to get the most up-to-date feature you calculate over time before the labels becomes available. In other terms, you need a time travel machine for your features with respect to your labels. For all those reasons,
Got an idea. Notebook LM. Let's go links, YouTube. Drop that guy. And then another YouTube link. This whole playlist. Wonder if it's going to recognize the entire playlist. That's kind of dope if it does. And then, so I got this one, that one. This guy.
In the last
That one. And we'll call this Vertex AI Study Guide. Hit me in the comments if you guys want this. I'm going to create several of these actually and just kind of see where we get to. And then I can go Vertex AI support documentation. Get this guy. Then I'm going to have this right here. I want that. I want that one. This one, of course, and then maybe this right here. There's so much, man. I'm just a marketer. I'm just a marketer. Leave me alone. Something like that. So I imagine I could go here and go data sources this way. I got my links, so I can just do this. Keep doing it. There's got to be a way to do this like fast, bulk. That'd be kind of dope. I don't know if that's available yet, but when it is, I will be using it. So we got this one, this one, this one. I mean, obviously this doesn't, nothing would replace actually learning it through and through. But I'm going to use an assistant to kind of build a study plan for me around ML ops and using some of these tools that I'm not yet familiar with. I might call this series like becoming a data scientist or something. Um, but doing it in a self-taught way, obviously. So for me, I've gotten as far as I have through self-taught means, and obviously there's more to go, but it's kind of cool to be able to get places.
Reason I just mentioned, you may decide to introduce a feature store, which provides you a service that helps you to address data leakage by providing point-in-time lookups, which fetch the most up-to-date features with respect of the time labels become available. And at the same time, it serves those features at scale with low latency, as they were available at training time, mitigating the way possible training and service queue. So once you ingest the features into the feature store, you are ready to train your model offline. You fetch a sample of them aligned with the label into a notebook environment. You use this sample for running experiment by defining different training configuration and tracking model evaluation metrics. And once you find the best modeling approach, you formalize the model training as a pipeline component. Then you easily integrate that component in a machine learning pipelines that allow you to cover all the steps required to reproduce the model training at scale. And only if the model achieves certain threshold levels in performance metrics, then it goes deployed to serving environment for generating online prediction when a new request will require. Notice how the feature store passes the same aggregated features you have calculated offline to train the model to produce online predictions. In other terms, it solved the training service queue I mentioned so far. All I show you until now, from feature store to model training with pipelines and the model serving, can be implemented on Vertex AI, which provides you all those capabilities by letting you keep focusing on your code and improving the quality of your solution. And talking about the solution, let me show you what we got. This is Fraud Finder, the data application we worked on. Once you pass some parameters, such as the feature store resource name and the endpoint ID, you can start streaming the transactions that are generated for a data synthesizer we built in the backend. After a while, if you go in the predict view, you can see in yellow the transaction that were classified as a fraudulent with respect to a particular probability threshold. And if you change it, you can verify that the frauds becomes less frequent. Lastly, under the dashboard view, you have the profile of latency, which is represented by the distribution of prediction requests over a fraction of a second. As you can see, the backend is doing a good job. Okay, this was just an example of what you can achieve by leveraging Vertex AI for MLOps. We are at the end of this journey. To conclude, you start from a system that has bias because rules were written by SMEs based on their knowledge. It was hard to scale because rules required to be hard-coded. It was hard to maintain because of the dissolve rules it generates. And today, I show you how you can solve those challenges with a simple fraud detection system which leverages both data to train machine learning models and Vertex AI platform to productionalize them. So now that you know that this is possible, it's your turn. Open the console and start building and putting your models into production using Vertex AI on Google Cloud. But don't forget one thing. All I presented today was possible because different people with different skills and backgrounds decide to join, work together, and learn from each other as a team. This is just to say that machine learning is a part of the picture, and MLOps is about culture, practice, technology, but more importantly, people. I hope you enjoyed the session. Thank you, and see you soon.
That has happened in the industry when it comes to generative AI is that software developers and even business people are able to interact with these models so easily. They don't have to, they don't necessarily have to train anything to start getting results very quickly. And so a lot of the experimentation to see whether a model is good for my use case can actually be done.
Looks like
by
someone's been digging
as well
deep into generative AI and Google's Vertex AI platform.
Definitely some fascinating stuff in here.
Yeah, 3 videos all about Vertex AI, what it can do, how it's being used out there, and another one that goes deep on how to manage those, well, massive machine learning data sets inside Vertex.
I'm sensing a theme here. Someone's ready to put this knowledge to work.
Exactly. And that's what this deep dive is all about. We'll break down Vertex AI, how it's changing things for businesses, and who knows, maybe you'll even walk away with some brilliant new ideas.
Sounds like a plan. Let's kick things off by defining Vertex AI. What exactly is it, and why should we care?
Well, one video called it, and I'm quoting here, a complete set of capabilities and solutions for building AI.
It's a mouthful, right?
A little bit, yeah. Kind of overwhelming.
Think of it as your one-stop shop for AI. Vertex AI brings together everything you need: data prep, model training, deployment, and keeping an eye on things after launch. All in one platform, which is pretty amazing when you think about how complex AI can get.
And it's not just having a bunch of separate tools, is it? This thing's connected to other Google Cloud services.
Yeah, you got it. Imagine all the building blocks for your AI project ready to go.
Regardless of your experience level, too. That's what stood out to me.
Absolutely. That's the real power of Vertex AI. It makes AI accessible. Now, something that popped up a lot in these videos is generative AI.
It does feel like that's taking center stage, doesn't it?
Generative AI is a big deal, and for good reason. It's a fundamental shift in how we use AI. We're going beyond systems that analyze data.
Now we're talking about systems that actually create new content.
Exactly. Think models that can write text, compose music, or create images, things we're seeing more and more in our daily lives.
One video showed Estee Lauder using it for personalized customer experiences on their website. Instead of generic content, customers get recommendations tailored to them,
leading to more engaged customers, higher conversions, and a boost of brand loyalty. And that's just one example of what generative AI can do.
Marketing magic is cool, but there was also that Fraud Finder example. Using AI to catch fraudulent transactions, like in real time. That's a serious problem.
It is. Fraud Finder highlights how generative AI can tackle real-world challenges. By analyzing patterns and anomalies, it can flag potentially fraudulent activity instantly as those transactions are happening.
So it's not just about creating catchy slogans or writing website copy. It's about using data in a totally new way.
Exactly. It's less about AI replacing us and more about AI giving us better tools to solve problems.
Now let's talk about this model garden thing. It sounds like a playground for AI enthusiasts, right? All these pre-trained models ready to use.
Think of it as a treasure trove of AI building blocks, a curated selection of models from Google, the open source community, and even big names like Meta and Anthropic.
That is Llama 2 is in there, right?
It is, along with Anthropic's Claude 2. There's no need to start from scratch. Just find a model that fits your needs and go.
It's like an app store for AI. But instead of games and productivity apps, it's models for generating text, creating images, even more specialized tasks like embeddings.
You remembered embeddings. See, this deep dive is already working.
Okay, I try to keep up. But seriously, remind me what those are again.
Imagine taking text, images, any kind of data really, and converting them into a format that captures their meaning and how they relate to each other. Those are embeddings.
So instead of comparing words or pixels directly, you're comparing these numerical representations, looking for connections and similarities that way.
Precisely. That opens up so many possibilities. Advanced search, recommendation systems, even things like plagiarism detection.
Okay, that's pretty powerful stuff. But let's say I find the perfect model in this model garden, but it needs some tweaks to fit my specific needs. Can Vertex AI handle that?
Absolutely. Vertex AI has powerful tools for customization and fine-tuning those pre-trained models. You can use techniques like transfer learning to adapt a model trained on a massive data set to your specific task and data.
So you're not training from scratch, which can take forever and use a ton of resources. You're giving it a head start.
Exactly. You're using what the model already knows and then fine-tuning it for your unique requirements.
Now, let's talk about something that's on a lot of people's minds. Responsible AI. How does Vertex AI address all those ethical concerns we hear about?
Responsible AI is not just a buzzword. It's built into the core of Vertex AI. The platform integrates features that promote ethical AI development, from data preparation to deployment.
One of those features mentioned in the source material was the content moderation API, right? That sounds important.
It is. The content moderation API lets you set controls over what your models can and cannot say.
I imagine that's super important for, say, chatbots.
Yeah.
You want to make sure they stay on brand, don't say anything offensive or inappropriate.
Exactly. It's about making sure AI reflects the values you want to see in the world. And then there's bias. We've got to address that too.
Vertex AI can help with.
Right. Vertex AI includes tools for bias evaluation. So you can check whether your model is treating different groups fairly, especially crucial for things like loan approvals or hiring decisions, where fairness is absolutely paramount.
So you can see potential bias in your model and correct it.
Yeah.
Make sure decisions are based on data, not harmful stereotypes.
It's about building AI that's inclusive and equitable. And all of that starts with data.
That's pretty cool.
Good data is the foundation of any AI project.
Garbage in, garbage out, right?
Exactly. So what kind of data can Vertex AI handle? Well, it can handle pretty much anything you throw at it. Images, tabular data, text, even video. It's designed to be versatile, ready for all sorts of data challenges.
Can you give me some specific examples, like for images?
Sure. One video mentioned using images to identify dog treats in product photos, detecting vegetables in a salad to analyze nutrition, and even breaking down sports videos to see player movements and strategies.
Okay, that's cool. What about tabular data? The kind of stuff you'd see in a spreadsheet.
Think sales predictions, forecasting sudden events that could disrupt your supply chain, or personalizing marketing campaigns based on customer data. Tabular data is the backbone of so many businesses, and Vertex AI helps you unlock its full potential.
So finding hidden patterns humans might miss. What about text data? That seems like a whole other beast.
It is, but Vertex AI is equipped for it. It leverages natural language processing, or NLP, to analyze text. One source talked about classifying customer support emails to route them to the right department, extracting key phrases from documents, and analyzing social media to understand how people feel about a brand.
Applications in almost every industry. And what about video? Is that even possible?
It is, and it's becoming more and more important. Think about automatically labeling commercials during a game to track ad spending or analyzing a football's motion to help players improve their technique.
Wow, okay, so Vertex AI can handle pretty much any type of data. It's like the ultimate data Swiss Army knife.
You got it. And we haven't even touched on everything it can do. There's one more component that's a game changer for real-time AI systems: the feature store.
Okay, the feature store. We keep hearing that name. What's so special about it?
The feature store tackles a big problem in real-time AI: data consistency. Imagine you're building a fraud detection system that uses real-time data. The problem is that data is always changing.
Which could throw off your model's accuracy. That makes sense.
Right, so how do you deal with constantly changing data? The feature store acts like a time machine. It stores all those data points, those features, used to train and run your AI models. They're all tagged with a timestamp so you know exactly when they were calculated.
So it's not storing raw data like names or transaction amounts. It's actually transforming that raw data into these derived features that the models can understand.
Exactly. It's not just storage. It's about creating meaningful features that help the models make sense of the world. Like instead of just knowing a customer's transaction amount, it might calculate their average spending over the last week or flag sudden spikes in spending.
And it keeps track of all these features over time, right?
Exactly. So if you're looking into a suspicious transaction from a week ago, you can instantly pull up all the relevant features as they existed at that specific point in time.
No more scrambling to reconstruct historical data or worrying about inconsistencies.
The feature store handles it all, making sure your models are trained and evaluated on accurate, consistent data, which ultimately means more reliable predictions.
Okay, I'm starting to get this. So we talked about using those pre-trained models from Model Garden and fine-tuning them, but are there other options for people who aren't, coding experts?
Absolutely. There's something in Vertex AI called AutoML, which stands for Automated Machine Learning.
AutoML, is that like an easy button for building AI?
Not quite an easy button, but it definitely makes things a lot easier. AutoML automates a lot of those complex steps involved in developing a machine learning model, so it's a great option for people who might not be coding whizzes.
So even if I don't understand all the technical stuff, algorithms and all that, I can still use AutoML to build an AI model.
Exactly. Let's say you've got a data set of customer information and you're trying to predict who's most likely to, say, cancel their subscription. With AutoML, you just upload that data, tell Vertex AI what you're trying to predict, and it figures out the best model, fine-tunes all the parameters, even evaluates how well it performs.
So it's like
That's
Vertex AI
interesting.
does all the heavy lifting, and I can focus
Yeah,
on
I
the
gotta.
actual business problem I'm trying to solve.
It's about empowering more people to use AI, build AI solutions without being a machine learning expert.
Okay, this is really cool. Now, I know there are different types of machine learning models, right?
There are.
We've talked about classification and regression, but what are some of the other types that Vertex AI supports?
Yeah, this
Another
is
important one is forecasting, using historical data to predict future trends.
Forecasting, right. That's huge for so many businesses, predicting things like sales, inventory, demand for products and services.
Imagine you're
Yeah, this guy right here. See where I get with it.
You're a retail company trying to figure out how much stock to have for the holidays. With Vertex AI's forecasting, you could analyze past sales data, seasonal trends, and even factor in things like economic indicators to build a model that predicts future sales with a high degree of accuracy.
That would be incredibly helpful, not just for inventory, but planning, marketing, staffing levels, all sorts of things.
Forecasting helps businesses plan for the future and ultimately improve their bottom line.
So we've talked a lot about building and training models, but what about actually using them? How do we put them to work? How does Vertex AI handle deployment?
Vertex AI offers several deployment options. You can deploy your models for batch predictions, which is good for processing large data sets offline, or for online predictions where you need results instantly.
So batch predictions would be like analyzing a giant spreadsheet of customer data to generate a report. And online predictions would be like, I don't know, a recommendation engine that suggests products in real time as people browse a website.
Exactly. Batch for when you need to process a bunch of data at once online for those instant results.
Okay, that makes sense. But once your model is out there, how do you
Pretty
make sure
good.
it's working the
All
way
right,
it's supposed to?
well,
You need to keep an eye on things. That's where model
I'm gonna
monitoring
get
comes in.
going.
So how does it-
I'll come back with more of these depending on how this does. I'll keep switching up pretty much the topics that I'm looking at while I'm on this stream. I think it's important to show you guys like a full look into my day and what I have to do to stay on top of things and what projects I need to be working on. So this whole Vertex AI thing is over my head as of today, but I bet a week from now I'll probably have um, the building blocks in place to at least play around with it and start experimenting with a data set. And I'll capture that for you guys so you can see the process. I think it's very important that I provide that value and get known for being the guy who is good at learning how to learn, especially in the technical space, and then teaching you guys how to teach yourself, essentially. So I think it's kind of one of those things to where it gets kind of artsy and I guess abstract in a way to where my approach and my philosophy towards the work that I'm doing, why I'm showing this to you guys, and what it means to kind of connect all this stuff back while also being a data analyst and also dumbing it down enough to where I can just speak to C-suite about it. So business people don't want to hear all the ins and outs of all the technical mumbo jumbo, but part of what I have to do is um, learn how to use all this stuff. So I think that once I come up with the best use cases, it's going to get very valuable. And maybe there's a better way to use Notebook LM. If you guys have any um, thoughts on that, or currently you're using Notebook LM in
Welcome
a
to
cleaner way. I'm just kind of caveman in it right now. Copy paste, copy paste. Um, I do think that there's
How does
room
that
for
work with
improvement, and I
Vertex
look
AI?
forward to it.
Vertex AI
All right, peace.